Okay, so hello, good afternoon, everybody. And today I'll be presenting this work done in collaboration with a fantastic group of people from Technology University Institute and the University of Pisa. This work is entitled The Power of Noise, Redefining Retrieval for RAG Systems. So why redefining retrieval? So we know that retrievers are usually used for search engine-like tasks, but nowadays, with the introduction of large language models, there has been a sort of paradigm shift of the use of retrievers, in particular with interaction with generators or large language models. In this paper, we want to analyze this interaction, this interplay between retrievers and generators, and we focus on a particular question. The question is the following. So, are current retrievers ideal for RAG systems? And why ideal? There have been different works studying the relation between retrievers and generators. Famously, one of them is the well-known Lost in the Middle paper. The authors show essentially that LLMs are not invariant to position changes of relevant information. If you place relevant information in the middle of the context of an LLM, then you have a significant drop of accuracy and performance in general. So this is like what we'll analyze in this research. So let's take a step back and see how can we get to this interplay that we call retrieval augmented generation. So let's start with the generation part. We have a large language model. You know that you may ask different type of questions, like the following, and you may get back generated answers. Here I would like to highlight possible issues to these questions. So in general, to generation, are the following. We have hallucination, the fact that LLMs may generate non-factual information. Then another point is that you may have, once an LLM is trained, their internal knowledge is fixed. So it cannot automatically update their knowledge. So it may generate obsolete information, right? Then this is also related to another issue, I would say, that it cannot manage personal information. So if I ask it how old is Florin, probably it will not answer correctly because it doesn't know who is Florin unless I'm famous, right? So in order to mitigate these issues, there has been introduced this new framework called Retrieval Augmented Generation. I'll go briefly through it. So the main point here is that knowledge source, like Wikipedia. We have up-to-date information and want to use this information to augment the knowledge of LLMs. We have an initial phase of indexing, like a data processing part, when you organize your data in chunks or passages. Then we have the main actor, retriever. Then based on a query, it selects documents from this knowledge source according to a similarity metric. And then we need to build sort of the input to an LLM, and we call this phase prompting. And now we have the input ready for the LLM, so then there is the generation part, right? In this paper, we'll focus on the retrieval aspect of RAG. Again, are current retrievers ideal for RAG, okay? In order to tackle this question, we thought, so what is the interaction? So how is happening the interaction between retrievers and generators? It's happening through text. So there is a retrieve text, and then you pass this to an LLM. Therefore, our analysis is starting from there. So the types of documents a retriever can fetch. We assume three main types of documents that a retriever may return that are the following. We have relevant, distracting, and random documents. Relevant documents are the ones that contain the necessary information to answer the query, or what we call gold document, the one directly containing the answer for a query. Then we have distracting documents. These are the ones that are semantically close and related to the query, but don't contain the answer. In practice, these are the documents that have a high retrieval score but don't contain the answer. Then we have completely unrelated documents, what we call random documents. Now, let's build a prompt for an LLM and follow what we did in the paper. So we have an input, a blank input, okay? Let's start with the task instruction, what the LLM should do. Now, let's add a goal document, a document that contains the answer about the color of the Napoleon's horse. Then, let's, for instance, introduce a distracting document, something that is related to the Napoleon's horse, but is not the one that allows to answer. In this case, could be chunk 2, right? The one talking about the horse of Napoleon's wife. And last, we have the query. The task instruction, the query doesn't change in this prompt. What we do is we change the position and the number of distracting documents in the prompt in the following. So now let's think a second. So what happens? We have this distracting information in the prompt. We can think that when we use this information, the LLM may be fooled by this. So probably it can answer wrong because this information of the color of the Napoleon's wife may distract it, right? Now, let's see what happens in practice so when using Llama and real-world LLMs. This is the scenario with goal plus distracting. We have 3 scenarios, okay? Far, mid, and near, that are about the position of the goal document with respect to the query. In the far, the goal document is placed far apart from the query, which means that in between we have distracting documents. Mid is when the goal document is placed in the middle of the context, or in the middle of the prompt, and then so it is surrounded by distracting documents. Near is when the goal is close to the query. Now, these are the results for Llama 2 7B chat, which is the instruct version of Llama 2 on the open version of natural questions. So here we have in the prompt only the goal document, nothing else, and the task instruction, of course. Now let's see what happens when you introduce distracting documents, the ones that are semantically related but don't contain the answer, okay? These are the results. We can see here that in all 3 cases, there is a strong degradation in accuracy. The worst scenario is the mid one. So do you remember lost in the middle, right? We have a degradation of about 68%. Whereas the near setting, when the goal is close to the query, is the best one. Because there is a degradation, of course, but it is only about 33%. And I would say that we see that distracting documents are really damaging the system. And I would like to highlight that these are commonplace in retrieval, because not all the retrieve documents are the one containing the answer to the query, right? And this is what happens with distracting. So do you remember the completely unrelated information? Like, let's put some novelist things in a prompt talking about Napoleon's Wars. We have random documents. So we may expect that probably an LLM ignores it, or there could be a sort of little degradation when introducing such documents. So let's see. In this case, in the particular in far and mid, there is a degradation again when introducing random documents, but it is less. So it is only about 47% with respect to the 68. And this is the far and mid. Now, consider the case when you place random documents, a goal document, and then the query. In that specific case, it happens the following. There is an increment, and which is statistically significant, or about 4%. This was completely unexpected. So why this is happening? So you put random stuff, and the model is able to better answer to the query. So we wanted to understand something, and we analyzed the attention of the LLM when using distracting and random documents. On the left, we have the case with distracting, on the right with random. This is when I ask to the LLM the same query, in the near case, so we have the goal document close to the query, so it's last in the context. And with distracting, the model is wrong. With random, is correct. On the x-axis or axis of this plot, we see the number of the documents in the context. On the y-axis, the hidden layers of the language model, so the number of transformers block. We can see that here, a particular cell is the attention from the generated tokens of the model, so from the answer, to the tokens composing the document, so a document. And the darker this color, the more attention the LLM poses to that particular document. You can see on the left, when it is wrong, that it's true that it poses attention to the goal document, but also to the distracting ones, in particular to the document 0. Whereas in the goal plus random case, the model is like almost ignoring the random stuff and really focusing on the gold information. Indeed, then is able to extract the answer from this. Up to now, we have seen like a scenario, a setting where we manually build the prompt, because for a query, we know what is the goal document, where to place it, and so on, then how many distracting, and so on. Let's see what happens when using RAG in practice. So you took your favorite retriever, in this case contriever, it retrieves some documents, and then you place this in the context. So let's see what happens, okay? So here we see the number of retrieved documents from 1 to 10. These are the results again from Llama 2. And now let's add some noise, so what we call random documents. In this case, that is the near scenario as before, and as before there is an increase, we see that the model, for instance, with 4 retrieved documents and 15 random, gets an increment of about 35%, which is a lot. So it's simply random stuff. Now, this is saying that something is not right optimal in the interplay of retrievers and reasoners, or LLMs. So getting back to our original question, are current retrievers ideal for RAG? Then probably the answer is maybe not. So it's true that RAG systems are really helping mitigating the problems of LLMs, hallucination, obsolete information, so on. But we're not ready to say that this passage of documents is ideal. In particular, I would say one point, so that we're using such systems as if they are search engines. So in a typical search engine scenario, we have a query. Then we have a retrieval module that outputs some documents. And at the end, there is an end user, usually is a human, that is able to understand what is relevant and what is not. Now, if you translate this to RAG, the end user is not a human anymore, is an LLM, which seems to not be able to discern between relevant and distracting information. Moreover, there is this thing about random that seems helping it. So something is strange. In conclusion, these are the main insights from this paper. So we have that relevant information should be close to the query, probably for how attention works. And in relation to this, also, distracting documents are like confusing the model, sorry. And last and more surprising is that random documents are helping the system, and these are increasing their effectiveness. In addition to this, I would say that another point is also important how we evaluate these systems. Because it's true that we have retrievers and reasoners that when collaborate, in a sense, probably they are not optimal, but also the evaluation probably is not optimal. Therefore, there should be further research on evaluation and on the interaction of retrievers and LLMs. Okay, this ends my presentation. Thank you.